Alrighty then, whoops, 6.5, indirect proof of inequalities in a triangle. Indirect proof, and then inequalities in a triangle. So first thing we're gonna have notes, page 336. Right here on page 336. Page 336, you can put that in your notebooks. So indirect proof, so first thing you're gonna do is identify the statement you want to prove. Assume temporarily that this statement is false by assuming that the opposite is true. Step 2, reason logically until you reach a contradiction. Now, a contradiction is when you have two statements that cannot be both true or both false at the same time. They contradict each other. Okay. Step 3, point out that the desired conclusion must be true because the contradiction proves the temporary assumption false. Okay. So this is called indirect proof. Uses indirect reasoning. So you start by making the temporary assumption that the desired conclusion is false. So let's say this. You're given triangle ABC, and you have to prove triangle ABC can have at most one right angle. At most one right angle. All right. So we have to say, this is what we want to prove. Well, let's assume the opposite. Can have at most one. We're going to assume instead of at most one, we're going to say it can have more than one right angle. Okay? Well, let's do more than one right angle. Let's say we know that in a triangle, the three angles in a triangle add up to 180. Inside a triangle, these three angles have to add up to 180. Okay? What happens? You can't have four right angles because a triangle only has three angles. So let's say it has three angles that are right angles. So let's say A is 90 degrees, angle B is 90, and angle C is 90. So 90 plus 90 plus 90 equals 180. Wait a minute. That doesn't work because that's 270. So there's a contradiction in that. It doesn't work. This is not equal to that. All right. Let's just assume that just two of them then. Angle A is 90, angle B is 90, and we'll figure out what C has to be. So 90 plus angle C equals 180. But wait a minute. Just these two together make 180, and 180 plus what equals 180. So now we've shown that the only way to make this work is if angle C is 0 degrees. You cannot have an angle of 0 degrees because that's called a ray. So that also cannot be true. So our assumption that we said, hey, that we can have more than one right angle, well, we just proved that you can't, because if you do, it leads to a contradiction. So therefore, our statement then says, we temporarily assume that a triangle can have more than one right angle. That has to be false because it won't work. Doesn't matter if it's three right angles or two right angles, it won't work. So that means our statement, our original statement, must be true. Okay, it's a proof by contradiction. Okay, that's why you have it in this right here. It's proof by contradiction. So make sure you put this in your notebooks. Okay. So when you get to the assignment and it says, here, let's do an example. It says right here, write the first step in the indirect proof of the statement. So if blah, 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 and blah, 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 then this. So the conclusion comes after the word then. So this is a conclusion. WV does not equal 7 inches. Well, what's the opposite of that? Assume WV equals 7 inches. Okay. This one, if blah, 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 then blah, blah, blah. Well, it's the stuff after the word then. This is the conclusion. Hypothesis conclusion. We have to temporarily assume that this is, assume the opposite. Well, what's the opposite of X, Y is odd? The opposite would be temporarily assume X, Y is not odd. Don't say even, just say X, Y is not odd. That would be the opposite. Okay. Next thing in your notebook, we have for your pleasure this right here, this, don't put this in your note. That just doesn't make, yeah, it's not good. Yeah, this is just too much. Gotta do this instead. This will make more sense. So right here, put this in your notes. In a triangle, the longest side is opposite the largest angle, and the smallest side is opposite the smallest angle. The longest side is opposite the largest angle, and the smallest side is opposite the smallest angle. So here you go. Here's a triangle. Here's the longest side, so the opposite of that is the largest angle. If you say this is the largest angle, then the largest side has to be opposite that, and that has to be the longest side. Same thing goes true for the smallest angle. If this is the smallest angle, then the side opposite of that must be the smallest side or shortest side. Okay? If this is the shortest side or smallest side, then the angle opposite of that must be the smallest angle. Okay? That's going to make things a lot easier in the future. So let's say we have something like this. In this case, we have a triangle, CIS, and the sides have 8 units, 9 units, and 12 units. Okay, let's put meters on there. Just 8 meters, 9 meters, and 12 meters. Okay? Well, we're going to write the angles from smallest in length to largest. I shouldn't say in length, but smallest to largest. The angles, well, which is the smallest side? That's the smallest side. So this is the smallest angle. So S, angle S. And the largest is the middle. The largest one is going to be here. The largest one, this is the largest side. So the largest angle is angle I. Angle I. So that means the middle one is going to be angle C. So from smallest angle to largest angle. What about for sides? The smallest side is this one. Side CI is the smallest. CI. That's the smallest side. The largest side is CS. CS. And the middle side is IS. The sides written from smallest to largest. CI, IS, CS. Boom. Done. What about this one? Now you get, huh? Well, how do we figure this out if you don't give it? Oh, we know that the 3 angles in a triangle always have to add up to 180 degrees. The 3 angles in the triangle have to add up to 180. So 80 plus 70 is 150. 150 plus what is 180? 30. That has to be 30 degrees. Okay? Angles. Angles. The smallest angle from smallest to largest is this one, T. Angle T is the smallest. The largest is this one, U. Angle U. It's a large. The one in the middle is V. Angle V. Okay, what about sides? This right here. Oh, sorry, smallest. That's the smallest angle, so smallest side is this one. UV. UV. The largest angle is this one, so the opposite of that would be this. That's the largest side, TV. And in the middle is going to be TU. TU. There you go. Some other people do it this way. If the angle is T, angles are written in capital letters, sides can be written in lowercase. So if that's angle T, the opposite side would be side T. This would be angle U. The side opposite of that would be, yeah, it doesn't work well for lowercase. Same thing here. Sorry. That one is definitely lowercase, but that's the same. Same for V. Upper and lower looks the same for V, and for U, upper and lower looks the same. Bummer. I should have used different letters. Anyway, we have that. There you go. Then we have the next thing for your viewing pleasure in your notebooks. Page 339. Put this in your notebooks. Put this in your notebooks. Triangle inequality theorem. It states the sum of the lengths of any two sides of the triangle is greater than the length of the third side. Okay, here's a triangle. Okay, let me go ahead and copy that. It's on page 339. Now I'll show you a way how this stuff is used. Let's say we have a triangle with, sorry, this is going to be similar to question 21. Is it possible, right here, is it possible to construct a triangle with the given side lengths? If not, explain why not. So this is similar to question 21b. So this is not 21, it's 21b, so it's similar to question 21. So this right here, can you make a triangle with these lengths? So this is what I want you to do. You take the two smaller sides, this one and this one. This small side and the medium side, if you take these two and add them together, it should be bigger than that one to make a triangle. So if 6 plus 8 is greater than 12, we can make a triangle out of it. If 6 plus 8 is not greater than 12, then you cannot make a triangle out of it. So, is this a true statement? Is 14 greater than 12? Yes. So that means, yes, you can make a triangle with these lengths. Okay? The answer is yes, you can make a triangle. What about in this case? You take the two smaller sides. These two are smaller. 4 plus 9. If 4 plus 9 is greater than 14, we have a triangle. We can make a triangle with these lengths. If it's not, it won't work. 4 plus 9 is what? 13. Is this a true statement? Nope. That's not a true statement, which means you cannot make a triangle with these lengths. I don't care if it's in meters or inches or feet or miles, it won't work. What about something like, come on, there we go. What about something like this? The two smallest sides are 3 and 8. So if we take, if 3 plus 8 is greater than 11, 3 plus 8 is greater than 11. If that's true, then we can make a triangle out of it. 3 plus 8 is 11. Is 11 greater than 11? I'll rephrase that. Is 11 greater than 11? I'm not saying equal, I'm saying greater. 11 greater, no, it's not. That's equal to that, but this is not greater than that. So nope, you cannot make a triangle given those three lengths. Okay, so if you have something like here, if you have one length like this length, let's zoom out some more. If this is one length and this is another length, so right there, these are two lengths. The other length, if it's shorter than this, you're not going to be able to make a triangle out of it. It has to be more than that. So that's going to be your short length. What if you put these end to end like this? Now, does this fit here? Now do we get it in the camera? There we go. So if you take these two lengths and put them end to end so they're touching like this, a side that's longer than this, it will not be able to make a triangle out of it. So the other side has to be shorter than these two. So this would be for the next part. And I'll show you how this stuff works here over here. Boom. Question 17. Describe the possible lengths of the third side of the triangle given the lengths of the other two sides. So if you're given these two lengths, if you're given these two as lengths, right here, 5 feet and 9 feet, if those are lengths, would you be able to make a triangle out of this? Okay, so we're going to say 5 and 9. Put 5 feet. They have to be the same units, by the way, and they are. 5 and 9. So the other side is either going to be smaller than these two, or it's bigger than these two, or it's in between. If the length is in between, it's definitely going to make a triangle. So you don't need to worry about right here. Okay? So what if you go this way? So when you're in a number line, now I'm doing this, this works as long as this one's smaller and that one's larger. Add the two together. What's 5 plus 9? 14. Okay, going that way, and a number line, that's getting smaller, that's decreasing, that's increasing. You add to go that way, you subtract to go that way. So subtract 9 minus 5 is 4. So 14 and 4. So that means the third side, if one side is 5 feet and the other side is 9 feet, the other side has to be someplace in between 4 feet, 4 feet and 14 feet. Someplace in between there. It cannot be equal to 4 feet. It cannot be equal to 14. It has to be between 4 feet and 14, somewhere in between, anywhere in between, and then you'd be able to make a triangle. If it was exactly 4, now you have 4, 5, and 9. Is 4 plus 5 greater than 9? No, won't work. That's what it doesn't have. It's not this. This right here, it's not this. Okay? It's not this. That's not going to work. It's this. This means x could be 4, it could be 14, or anything between. And that's not what we want to say. We want to say it has to be greater than 4 and it has to be less than 14. Any place in between. So, what about if you have lengths like this? Okay. Write the lengths, put the smaller one on the left, the larger one on the right side. We don't have to worry about the number in between because we know that'll work. We have to worry about the smaller side and the bigger one. So going that way, add them. What's 14 plus 23? 37. There it is. It's on 37. So the third side can be up to 37. And what's the big minus the small? 23 minus 14. Excuse me. 9. 9. So we're saying if you have sides of 23 meters and 14 meters, the other side has to be between 9 units and 37 units. Actually, not 23, 9 meters, because it's meters, and 37 meters. So the third side has to be between the here and here. Now, keep in mind, these two things are not the same thing. This is not correct. It's not less than or equal to. It's just less than. So be aware of that. Okay, and the last one I'm going to show you is this one right here. Describe the possible lengths of the third side of the triangle given that the lengths of the other two sides are 132 inches and 9 feet. We got a problem here. Houston, we got a problem. That's in inches, that's in feet. How do you compare things when it's like saying apples and oranges? No, you did two different things. Yeah. How about we put those in the same measurements, same units? You want to put them both in feet or both in inches? Well, I'm going to put them in inches because it'll be easier to transfer in inches. Okay. 12 inches per foot, 9 times 12. 9 times 12, 9108. So 132 inches, and that's 108 inches. Now that they're in the same units, now it's easy to compare these two. If you left it like this, it's easy to make a mistake. So make sure you have the same units. Okay, now take the smaller one I put on the left, the bigger one on the right. So going that way, what's 108 plus 132? That's going to be that's 4 to 240. What's 132 minus 108? Going that way, we subtract. 132 minus 108, 22, 23, 24. Excuse me. So if you have sides, of lengths 132 inches and 9 feet, or better spoken, if you have sides of 132 inches and 108 inches, the third side has to be somewhere between 24 inches and 240 inches. Okay, there you go. Bada bing, bada bang, bada boom. Okay, let me see this right here, number 7's